video, we'll look at 3 different types of solutions: unsaturated, saturated, and supersaturated. Unsaturated solutions contain less than the maximum amount of solute that will dissolve under given conditions. The given conditions usually represent a specific amount of solvent and a specific temperature. So for example, the maximum amount of sodium chloride that can be dissolved in 100 milliliters of water at 25 degrees is 36 grams. Okay, so we've been given the maximum amount of sodium chloride that can be dissolved in 100 milliliters of water. That's the amount of solvent at 25 degrees. There's the temperature. Maximum is 36 grams. But if only 30 grams of sodium chloride are added to that 100 milliliters of water, it will all dissolve, and your solution is called unsaturated. We could dissolve more than 30 grams. The maximum amount is this 36. Maximum 36. I have 30. I have less than the maximum amount that would dissolve in 100 milliliters of water at that temperature. So we call the solution unsaturated, less than the maximum. Most solutions that we make and work with are unsaturated. If I wanted to, I could add another 6 grams, and it would dissolve. Now, another common question that gets asked, sometimes people will be asked, what is the final mass of the solution? I added 30 grams of sodium chloride to 100 milliliters of water. What's the final mass of the solution? Tricky question, eh? Maybe, maybe not. So you might remember that the density of water is 1 gram per milliliter. So 100 milliliters of water is also 100 grams of water. So here's the trick. You added the 30 grams of sodium chloride to the 100 grams of water, and now I've got this solution, but I don't see the sodium chloride anymore. So some people will say, final mass? I just see the water. Maybe it's still 100 grams. Wrong, right? In this solution, you got 30 grams of the sodium chloride plus 100 grams of water. It seems too simple, eh? It really is 130 grams of solution. But of course, one of the wrong answers is 100, and it gets picked a lot. And I don't know if people just think that because you can't see the sodium chloride, it means that it's disappeared in some way. And later on in this unit, we'll look at what's happening to the sodium chloride. Obviously, it's not a solid anymore, but the sodium and the chlorine are still present. They're still there, adding mass. Okay, unsaturated, easy. Most solutions we work with are unsaturated. So then a saturated is a solution that does contain the maximum amount of solute that dissolves under those conditions. If you add any more solute, which is in this case our salt, it will not dissolve. So if 40 grams of sodium chloride are added to the water, it's the same 100 milliliters of water, only 36 will dissolve. That 36, that was the maximum solubility at 25 degrees Celsius. I'll put that in there too. At 25 degrees Celsius in 100 milliliters of water. 36 was the max. So if I add more than 36, that's fine, but it's not all going to dissolve. 36 grams will dissolve, and the rest will remain undissolved. So essentially, up in here, there are 36 grams of sodium chloride dissolved. And the other 4 remain undissolved or solid. It's really easy to make saturated solutions. You take your water and you just dump in whatever your solute is. Sodium chloride, let's say. Just dump in some salt, stir it around. If it all dissolves, you are not saturated. So you add more. Stir it around and wait until you add enough salt that you finally see some solid remaining at the bottom of your beaker. Now you know that the solution itself has dissolved the maximum possible, because any extra is sinking to the bottom as undissolved solid. Makes sense, right? Now, supersaturated is a little funky. It seems kind of like an oxymoron. A solution that contains more than the maximum amount of solute that will dissolve under the given conditions. How do you get more than the maximum? Isn't the maximum the most? Weird. So you gotta mess with these a little bit. They're really tricky to make. In order to dissolve more than the maximum, you must initially increase the temperature. So you increase the temperature so that you can dissolve more than the maximum. And then you very carefully let that temperature cool back down to your 25 degrees or whatever it was. I'll make a supersaturated solution for you. I'll bring it to class. But they're tricky, so I maybe I maybe bat like 60% on them. Like as you let these cool, you can't bump them or anything like that. You have to let them cool very carefully so that the extra solid stays dissolved. Crazy. Okay, so I want to show you this graph. Oh, baby. You're going to see these on tests and quizzes and practice problems everywhere. This is a graph of solubility versus temperature for some common solid solutes. So notice in general, most of them kind of slope upward. As you increase the temperature, you increase the solubility, which is what this graph is measuring. Temperature of the solvent in degrees Celsius. And then this is the solubility. So this is grams of these solids that dissolve per 100 grams of water, or 100 milliliters of water. So some common questions. Interpreting a graph. This reminds me of like an ACT kind of question, where you just have to interpret the graph. The data is all there. What is the solubility of sodium nitrate at 60 degrees? Okay, so I find sodium nitrate. Maybe that's the hardest part. And yours on paper is probably not colored. So here's the sodium nitrate. On mine, it's like this blue line. That's 60 degrees. So 60 degrees, sodium nitrate. I don't know. It's like somewhere in there. I follow it up and then over. So I'm like maybe right around 120 grams. So that means that I can dissolve 120 grams of this sodium nitrate in 100 grams of water. That's what it means when they say, what is the solubility? This graph is for 100 grams of water, or 100 milliliters. That's the maximum amount I could dissolve. I'll put that down too. This is the maximum solubility. The graph tells you the max. What substance present on the graph has the greatest solubility at 80 degrees? Oh, Okay, so I find my 80 degrees Celsius, follow it up, boom. The greatest solubility is probably this potassium nitrate. Of all these substances, I could dissolve the most potassium nitrate in 100 milliliters of water at 80 degrees. Okay, this isn't so bad, right? Okay, so now here's a couple funky ones. If 30 grams of sodium chloride are dissolved in 100 grams of water at 60 degrees, will this solution be unsaturated, saturated, or supersaturated? Okay, so the key is to ignore that 30 grams of sodium chloride. Ignore the 30 grams. Let's look for sodium chloride on the graph and first find its maximum solubility at 60 degrees. Okay, so sodium chloride, mine is like this kind of orangey color, I guess. And we're at 60 degrees. So now we're kind of like right in here. And if I follow it over, I don't know, it's approximately 40 maybe. So we'll say 40 grams is approximately the maximum. The graph tells you the max. The maximum amount I can dissolve is 40 grams. Find that first. Now compare that to what you have. The maximum is 40. This is what I have. I have 30. So I have less than the maximum. That makes this solution unsaturated. The problem is people will sometimes do this opposite, where they'll look at 30 and then say, oh, but the graph says 40, and 40 is more than 30 supersaturated. But they don't really understand what those numbers mean then. The graph is telling you the maximum is 40. Then look and see, well, what do you really have? What does the problem give you? Oh, I have less than that. 180 grams of potassium chloride are dissolved in 100 grams of water at 80 degrees. See what kind of solution we have. So this is the potassium chloride at 80 degrees. I'm going to my graph first. Potassium chloride, mine's kind of this green line at 80 degrees. Okay, so maybe like somewhere in there. I followed across. And the maximum is maybe like 50. 50 grams is approximately my max. Now I look at the problem and see, what do I have? Holy buckets, we have 180 grams. That is way more than the maximum. There's no doubt in my mind then that this solution is supersaturated. They must have initially increased the temperature to dissolve all that extra potassium chloride and then just slowly let it cool back down. Do you kind of see where I'm getting at here? Find the maximum on the graph first, then compare it to the amount that you really have in the problem. And finally, 60 grams of sodium acetate dissolved in 100 grams of water at 35 degrees Celsius. Okay, so 60 grams sodium acetate. It's actually this funky thing. More commonly, we might write it like C2H3O2. And it's this weird looking formula. Mine's kind of a red line. All right, so what do I got here? 60 grams at 35 degrees. Okay, so I'm going to ignore the 60, whatever. I want to find the maximum solubility at 35 degrees. All right, so 35 degrees. Goofy red line. Okay, it's 35. And what do I know? The maximum is 60. So 60 grams is the max. And that is what I have. We are saturated. Find the amount on the graph first. That is the maximum solubility. Then compare that to the amount that you have. I have 60 grams. Now, a couple other little ways to spin this. What if they said something like this? 70 grams of the sodium acetate in 100 grams of water at 35 degrees, but 10 grams of solid remain undissolved. Okay, so here's another way of wording this. What if I added 70, but some of it remained undissolved? That's another way of saying saturated. Oh, wait a second. If 10 grams are undissolved, that really means that 60 grams did dissolve, and that's the maximum. Saturated. Or maybe they would say something like, if 70 grams are added to 100 grams of water at 35 degrees, how many grams of solid will remain undissolved? Well, again, that's where we would look at the graph to find this maximum solubility of 60 grams, so that if I add 70, I could tell you that 60 would dissolve and the other 10 would remain solid, undissolved. Cool. So we're going to practice with this graph. It's real common, and we're going to practice making these solutions. You're going to love it. Super easy.